Alright, so the first part asks you about heteroscedasticity and homoscedasticity. First, let's talk about what each of these mean. Take a look in this graph, which I got just straight from Wikipedia. If you just Google this word versus this word, you can find these respective graphs. So take a look at the data, all these little points inside this blue circle. Okay, and now let's look at all of the points inside this blue circle. Notice that they're part of the same group of data, the same graph. So let's look at how far apart all of these little points are. Some are very, very close, some are pretty far. So take note of how all of this looks. Now let's compare it to this circle up here. You can even make this a different color. Some again are very close and some are a little far. Now you are asked to judge this informally. So what this means is subjective. It means just to look at a graph of the data and judge what you think based on that. So I'm showing you how you can look at a graph of data to be able to determine that. So what we're doing is we're looking at how the data looks in this circle versus this circle, and in fact it's similar. It's similar in the sense that the space between all these data points is pretty much the same as the space between all of these. There's some that are very close, there's some that are a little bit far. Overall, it's basically the same. This means that the subgroups of the variance are essentially the same or very similar. This is called homoscedasticity. For any of these circles that I could make, you'll notice that all the data inside is essentially the same distance apart and everything like that. It's very similar throughout. So note that we are not talking about correlation. This data is very correlated, but that's not really what we're talking about. We're talking about the variance in these little subgroup circles. Now let's take a look at heteroscedasticity. Let's again apply the circles. So let's look. There's data that's very, very close, data that's a little bit far away. It's pretty similar to this circle here. These two seem pretty similar, the data inside. Now let's look at this circle and compare it to this circle. The data inside of this circle is pretty far apart. There are no data points right next to each other like this circle. The variance for these subgroups is pretty different. If we have one more, we'll also see it's pretty different than this and pretty different than that. This is what heteroscedasticity means. That even though they may look correlated and it's from the same data, there's subgroups with pretty different variance. So this is the difference between heteroscedasticity and homoscedasticity. So you have data already set up for you. You should graph it just like this, which is a scatter plot, and then judge what you think. You can maybe put these circles here and see what you think. The point is, it's supposed to be informal, as the instructions say. There are tests, and statisticians use tests to determine a concrete number, They don't just go by how the look of the graph is, although that can provide valuable intuition. So you are asked just to use your intuition by looking at the graph and determine which you think, heteroskedasticity or homoskedasticity. Now let's move on to the next part. So you should have this part already done. You should have your data for X, your data for Y. You should have charted it. You should have got an equation for that. You should now have your Y hat. Just to make a note, it's pretty easy to compute these values. I'm just going to type in that equal sign, the coefficient that you should see in this chart right over here, times an X value, and then plus the intercept, which is this number here. Press enter. You can see these match, and then I can simply just fill, and now it's actually using it for each X value that corresponds to where this is. So this is just a convenient way to put these in. Next, we need to find the residuals. If you recall, the residuals is the actual Y value minus the expected Y value, or the Y hat value. And it's the same idea. You can just type this in, use the fill, and we get all these values. So you should have this all done. If you don't, then just recreate it with the data that you have. So you should already be at this step though, so let's move on. Now this is going to look a lot right now. We're going to take it step by step and make each of these and show what they mean. So the Durbin-Watson test is essentially this formula. D is the number we're looking for. How can we get D? Well, we have to compute this and we have to compute this. What does this mean that we're computing? Well, recall this EI is the residual. The I is indexed for each residual. As a refresher, this would mean that E1 is this, E2, E3, and so on. So what we will do is take, for example, we are starting at 2, so we will take E2 minus E1, get some number, then we will square it, and then we will add it to E3 minus E2 and square that, and we'll go so on until we reach the last value. Now notice that I started E2 minus E1 because, as this summation shows, I equals 2. This is your starting point, and the equation is I minus 1. So it's 2 minus 2 minus 1, 3 minus 3 minus 1, and so on. The bottom part is very similar, only we start at 1 and we square it and then add it to the next one. So let's start actually making these. So first, let's do the easy part, which is this denominator. We simply, let's start by squaring it. So this will mark each residual squared. So all I'll do equals this times itself, which will square it, and then drag that down. Now we have the denominator. Next, we want this. So how can we set up this numerator? I'm going to paste this again. I mainly do this just so it is easy to see. The color and border also makes it easy to see. So what we want to do is have this minus that, this minus that, this minus that, this minus that, and so on. So what I'll do is just paste this over here. Too far down. Over here. And now look. This minus that is this minus that. And this minus that is this minus that. Be able to see exactly how this works, how this is surrounded by its top to its right. So if I did the bottom minus the top, it is now the same as this minus its right. It just makes it easier to see and easier to look at when we're doing the subtraction, easier to make the formulas work. So in here, we will have our differences. So let's compute them. We have this minus that. This is what happens if you make it error. Okay, so we have, this is the wrong order, this minus that. Just drag it down. We don't need this. Now you may wonder why it seems like this is shifted. We have 10 values here and only 9 here. This makes perfect sense though. If we had 2 values, we could only do one subtraction. Because we start at the second value, we would only do 2 minus 3. Which would just give us one number. So do not be alarmed that we have 10 here and 9 here. We should have exactly one less than we started. Okay, next we have the differences. We have to have the square differences. And this is just like anything else that we have squared. We simply equals, click it twice. That means it's times itself, which is equivalent to squared. And drag this down. Now we have all of the squared differences. Finally, we want to sum this and sum this. So let's put these on the bottom. I just type equals sum everything that I want to sum here, and then again equals sum everything I want to sum. Now, this is the numerator, this is the denominator, so I'll solve for D. And sure enough, we get what we had here, 2.304813. So you may want to pause, notice everything that's in this section. It's a bit more cleaned up, it looks a bit nicer. If you want, pause, look at the formula that we have here. Look at the formula here. And here. This is really just the difference. And the formula for here. So, now that we have this number, what does it mean? Well, I think if you have a textbook or something, you can look it up and determine what this number actually would mean. It's not that hard. It's not really a calculation, it's just what this actually means. So I think that would be a good thing for you to try and look up and understand.